We're going to take a look at slope from 2 points. So slope we talk about as a ratio or a fraction comparing the vertical change to the horizontal change of a line. So kind of the up and down and then the left and right you can think of. We often think of slope as the steepness of a line. So if you think about the steepness of a hill, we can think about it in the same way for a line. So if we're thinking about a positive slope, this is a slope that goes up from left to right. So we read slope kind of the same way we read words from left to right. So a positive slope would look something like that, where from going from left to right, you would be walking up a hill. A negative slope goes down from left to right. So if you were going from left to right, it would be going down a hill. When we're thinking about a line, lines are actually made up of an infinite number of points. You want to think about as many tiny little points as you can think of, all smooshed together. So if you just kept zooming in and zooming in and zooming in, there'd just be infinitely many points that come together to make up these lines. But we can use any two of these points in order to calculate the slope of the line. So we use the variable m to represent slope. And we said before that the slope is our vertical change divided by our horizontal change. Well, if we think about vertical, right, that's up and down. That's our y-axis. So this is the change in our y variable. Or we often write change as a difference of two values. Okay. Then horizontal, right, that's left and right, that's our x-axis. So on the bottom, we think about the change in our x value. And again, we represent that as a difference of two values. So we're using 2 points in order to get these changes. So you can see above, we have the formula for slope. So when we're calculating slope from 2 points, it's just a matter of using the formula accurately and making sure that we're entering in these points. So oftentimes I will note which one is going to be my first point and which one's going to be my second point. So a coordinate point is always an x variable followed by a y variable. So this is going to be our first. I'm going to call it x1 and y1. And the next one's going to be our second. So it's going to be x2 and y2. We need two values to find a difference, right? Two x's and two y's. So we said we have our vertical change first, and then our horizontal change. Okay, so vertical change is going to be the difference in our y's. That's our y variables here. So we have 4 minus 10. And then our horizontal change is the difference in our x's. So that'd be 2 minus 4. The important thing to note is that when you're subtracting, just make sure you're going in the same, kind of the same direction. So if we do 4 minus 10, right, left to right, you want to do 2 minus 4. Don't flip it and do 4 minus 2. Otherwise, things are going to get a little wonky for you. So we just want to simplify that. So that's going to be a negative 6 divided by a negative 2. And we always reduce our slope as much as possible. So negative 6 divided by negative 2 is really just 3. Let's do a couple more of these. So number 2 here, we're going to do the same thing. So we have an x1 and a y1 value, and then an x2 and a y2 value. So we're going to take the difference of our y's, the vertical first, 5 minus 9, divided by the difference of our x's. That's our horizontal, negative 3 minus 3. 5 minus 9 is a negative 4. Negative 3 minus 3 is a negative 6. And when we reduce, we get 2/3. Just make sure to leave your slope as a fraction. You don't need to write it as a decimal. In fact, you shouldn't write it as a decimal. It needs to be expressed as a ratio. Let's take a look at a couple more slopes here. One thing you might note before we even start this slope is that our y values are the exact same number. So when we're graphing this, we want to think about what this slope would look like if it was plotted. So say we had a little coordinate plane here and we wanted to plot these. So we would have the point maybe, let's see, 3, 6. And then we want to plot our next, so 3, 6, let's plot that point there. And then our next one would be negative 2, 6. So if this was negative 2, we'd put negative 2, 6 right there. And if we connect those, we get this nice, perfect horizontal line. So let's see what happens then to our slope when we go to calculate it. So we'll have difference of our y's, 6 minus 6, divided by the difference of our x's, 3 minus negative 2. Do be careful about your subtraction here. Make sure you continue subtracting. So we're going to simplify this. 6 minus 6 is 0. 3 minus negative 2 is really 3 plus 2, which is 5. And 0 divided by anything other than 0 is just 0. All right, so we have a 0 slope. Well, let's think about this. We talked about slope being the steepness, right? As if we're thinking about a hill. Well, a horizontal line is flat, right? It has no steepness. It's just a flat line. So it would be as if you're walking along flat ground. So a horizontal line has no rise, right? It has no up or down. It only has run. So it only goes left and right, and its slope is always going to be 0. All right, let's take a look at this next one. So this time, we notice something about these points as well, and that would be that our x's are the same. Okay, so let's plot this real quick. All right, so we're just going to go along and plot this. So we have the point 4, negative 2, so we'll put a little point there. And then we have the point 4, 5, so maybe 5 would be up here. So this isn't a really accurate graph, it's just a quick sketch to give us an idea of where we're at. So if we connect these, we have a vertical line. So before, our horizontal line had no steepness, right? If you're thinking about a hill, ooh, well, this is straight up and down. I don't know about you, but I have really never seen a straight up and down hill, only maybe a cliff face, right? So let's see what happens to our slope. So again, difference of the y's, so negative 2 minus 5 in the numerator, and in the denominator, the difference of our x's, 4 minus 4. Well, we get negative 7 divided by 0. All right, well, we can't divide by 0, right? So this here is when what we get is called an undefined slope, right? Undefined. So when we're thinking about a line that's straight up and down, we can't really define how steep that is, right? It doesn't really slant upwards or downwards. If you were trying to go straight up without any assistance, like climbing gear, you wouldn't be able to. You can't just climb straight up in the air with no help. So this is our undefined slope. We just express it as using the word undefined.